What we've been offering to customers for the last 40 years has been digitalisation. But the ironic thing is our own business wasn't digital at all.
If I look back at our Lean journey started in 2001, and it certainly is a journey that doesn't really have a destination.
Digitalisation is just a complete step change.
Hello, my name is Dusty Rhodes and you're welcome to our Engineers Journal Amplified podcast and the third in our special series shining a light on digitalisation and the impact it has had on Irish business and society. From 3D models in public planning to patients living with pacemakers, it's clear from the experts we've spoken to so far that digital advances are pushing sectors into new spaces that present them with unique opportunities, but not without their challenges. To assist us with our final dig into the world of digitalisation, I'm joined today by John O'Sullivan, Managing Director of Douglas Control and Automation, who has over 25 years' experience in the sector. Barry Lowe is Engineering Manager at Lufthansa Technik turbine in Shannon. Barry has a ton of international experience working in the USA and Germany in a variety of technical roles. And Andrew Lynch, Chief Innovation Officer at Irish Manufacturing Research and also a contributing expert on several key international policy directives for manufacturing. Gentlemen, you're all very welcome. Before we get into some specific projects, I kind of just want to talk generally about how technology plays a part in your day-to-day work. Andrew, if I could start with you, how has digitalisation shaped advanced manufacturing over the past 20 years or so?
A great question. I'm old enough, for those of you who can't see me, I have a grey beard. I'm in my I would say early 50s. I'm still a very pretty man. I'm very lucky in that context. But if you consider me as a young production manager, general manager on the manufacturing side all those years ago, and how I managed the facility and how I gathered information and how you made decisions based on the output of the data from that facility and so on. It was very manually driven, filling in manual charts and so on. Digitalisation is just a complete step change. It's a transformation. We now have the capability to look at optimization of a manufacturing facility. If you've got 60 different machines, you've got 150 different customers, you've got 1,000 or 1 million SKUs, we can now put that into a platform. It will figure out the fastest way that we can manufacture that good. It can even figure out the best way to do it, how much, the most cash flow in the month, our on time and full highest metrics that we can meet. So if we make a change on a digital twin, for example, we can see this at a digital or a non-real level. We can interrogate the system itself, we can optimize it, and then we can execute in the real world. So there's no financial commitment to doing something, but we can see the impact of doing that thing, we can do it and execute it in the real world. So it's transformed everything. I mean, when you think about it, we can scan in a part electronically into a machine and it'll build the part there and then using 3D printing. We've got AR, VR goggles. You can put them on your head, and when you're looking into the bed of a machine, an arrow will come down and it will point into a particular dial that should be at 7 instead of 8, and you can change that dial. We can use, we're at the edge of using, IoT sensors. I remember when an IoT sensor was, $1,000. Now they're less than €5. We can put these things anywhere. In 100 years' time, just to really encapsulate your question, in 100 years' time, people are going to look back right now at these 5 or 6 years, and they're going to say, that is when everything changed. And I will be telling my grandkids in years to come, please God, if I live and they exist, I'll be saying, I'll tell you what we used to do in manufacturing, and you're going to get a laugh. We used to put a manufacturing facility out in the middle of nowhere. We put people into it, we'd manufacture goods, and we'd manufacture way too many of them. And then we'd put them on trucks, you're going to love this, and we'd drive the truck to another big warehouse, and we'd put all the stuff in the big warehouse. And then we'd fly it all over the world, and you're going to love this, we'd put it into more warehouses, and then we'd drive it from that warehouse, and we'd put it into a shop, and people actually, this shop thing used to walk through the door of a big house, and there was lots of stuff for sale, and you bought stuff using a credit card, or, God forbid, money. Let me tell you about how money worked. So our grandkids are going to look at this, and they're going to say, you guys were nuts. No wonder you burnt the planet, because there's so many things changing in terms of how we do this. It's fantastic, a wonderful time to be alive in this space.
Let me go to John next. John, how has digitalisation shaped the automation industry in the last 20 years?
It's a path, it's a journey that we're on. And in my own personal situation, I'm doing some research and I'm researching techniques and technologies that we can bring to manufacturing. And it's how we get these new innovative ideas onto the factory floor. So what I've discovered just thinking about this for this podcast, I was thinking about what we do. What we've been offering to customers for the last 40 years has been digitalization and, parts of Industry 4.0 for a long time. So, our projects in process industry would be an electronic controller that controls the plant, then followed by a human machine interface screen where the operator can visualize the plant and visualize the process, up into the supervisory level where the supervisors are dealing with batch management and recipe management, and then up into the business where data becomes the product and the business has to evaluate life cycles and supply chains. So we've been offering this digital journey to our customers for decades. But the ironic thing is our own business wasn't digital at all because we're in this pharmaceutical regulated environment, a lot of paper, a lot of signatures, a lot of ink. So I've got two little stories. I suppose there's the story of how we're changing what we offer the customer, and then we have how we change ourselves. So COVID was a great accelerator of our digital journey. And even before that, we started moving to Office 365. Instead of having licenses on site, we're dealing with subscription-based licensing, moving storage from the site to the cloud. And even in COVID, we were at the stage where we were doing remote testing with customers in different locations. And right now we've moved our timesheet packaging to the cloud. We're moving accounting to the cloud, because when people are working at home, they need to access all this data that we're producing. So I think after 40 years, we're finally digitalizing ourselves. My colleagues in Siemens would have a phrase about drink your own champagne, take your product and use it. And I've heard other people use a phrase which is eat your own dog food, which isn't as nice as drink your own champagne. So I prefer drink your own champagne.
I got to stick with the latter, definitely, John. Barry, can you tell us, because you're in the aviation industry, how has digitalization journey changed things at Lufthansa?
So I suppose I'd like to go back to our lean journey. And when we talked about digitalization, we didn't relate it to lean. But if I look back at our lean journey, started in 2001 and is still a very active program within the facility and the company at the moment. And it certainly is a journey that doesn't really have a destination. There's always further improvement you can make. And when we looked at digitalization, as I said, we kind of started by looking at Industry 4.0. We'd heard a lot of talk about Industry 4.0, and we didn't really know what that would mean for our company, Lufthansa, here in Shannon. As John pointed out, we're a highly regulated industry as well, and historically, everything is paper, everything is stamped and signatures and all of that. So to make improvements, I suppose, a lot of our improvements were Kaizen events where we found more efficient ways to do the physical work we do and make improvements to our processes, very focused on our value stream map and eliminating waste. And then we looked at Industry 4.0. I suppose we started looking at, one was automation and two was information. We looked at an analysis of our labour, where our labour goes, and the highest utilisation of our labour was on blending, which is a very manual to repair the parts during the repair process. And I think the second one was blasting. Because we don't manufacture, we repair parts. Every part coming in can be slightly different. So therefore we need to have an adaptive process that can adapt to the condition of the incoming part. And that was really challenging, I suppose, for the blending. So we looked at robotic blending, and we also looked at adaptive machining, and we came up with technical feasible solutions, but we couldn't justify them from a commercial point of view. We then took our second significant manual operation, was just blasting, and we've successfully implemented robotic blasting for that and eliminated the manual element of that. Our plant is 30 years old. A lot of our equipment is old and it needs replacement. So over the last 3 years, we were going through an upgrading of a lot of our big pieces of equipment like milling machines, lasers. So whenever we were buying new machines, we were buying them not for our current process, but looking ahead to what we might need for the future. So that was a big change for us, was to look for the future and look at what we believed was required for the future. Then we had new technologies, like we've got 3D printing, which is laser blown powder directed energy deposition. So it's effectively taking parts that come out of an engine that are worn and being able to rebuild the material using this technology, which allows you to print like a honeycomb type structure. And that in the aviation industry was new technology and very difficult to get approval to do it. So we've been working with one of the aero engine OEMs to develop the repair, and it's been in development for about 10 years. We started production 2 years ago, and one of the things we wanted to do was to try and find a way that would reduce the amount of testing of parts to validate parts leaving the facility. So we've done a lot of work through digitalization, capturing the key process variables. The other big area is all of the parts we bring in that we have to repair, we have to restore the dimensions. So we've got to try and take a worn part and build up surfaces, add material to it, and then remachine it and grind it and coat it and bring it back to finished dimensions that comply with the requirements of the engine manufacturer. And a big part of that then is the whole quality control of the part, making sure the parts are dimensionally correct. Historically, that was all done manually, measuring it with maybe a micrometer or a vernier type calipers, and the inspector verifying that the dimensions were within the required tolerance. We now are moving to CMM, coordinate measuring machines, or we have a number of other digital measuring pieces of equipment where we can capture all of that data digitally, and that has the benefit of allowing us to actually have the measurements that were measured, rather than simply looking at a record saying yes, they were measured and found to be within the specification. We actually have the measurement, we have it measured automatically, so you're eliminating the human error really. Once you've your measuring system validated and calibrated, then you have a much higher level of confidence because you're eliminating that human element in it. So it's bringing about a lot of change on our production floor, but what we're looking at now really is looking more on the other processes, whether it's our customer service or our finance, looking for where we can use digitalization to improve that. And I think one of the big changes for us was we identified an IoT platform, ThingWorks, which effectively allows us to dump data from our machines, from our measuring systems, from our ERP system. We can extract whatever information and dashboards we want from that going forward. So that for me is probably the most significant step, that we now have that platform that we can build on.
So all three of you are saying that, you're all from vastly different sectors, but they're all becoming reliant on digital systems, and speed and efficiency and accuracy are all seeing a huge improvement because of this. Let me go back to Andrew, because Andrew, you kind of work on a bit of an overview level because you're doing a lot of things in the EU as well. And another thing that you're very conscious of in our changing business these days is circularity. What exactly does that phrase circularity mean?
Circularity is quite interesting because it's this idea that we're in a circular environment. In other words, you take something, you create something, you break that down, and you use some of the breakdown product back into the system itself again. It's like trees, for example. They grow up, the leaves go down, they become compost, they nourish the tree, and away we go again, and we can see it. It's that idea around circularity in that context. And I think it's a beautiful idea, but one of the key tenets that I keep saying to people is that there is no circularity without the manufacturing sector. So when we look at manufacturing at a European level, I like to do this every so often because I think it contextualizes it. We do not have the raw materials that we need to support ourselves in this geopolitical region. We've got to go into Africa or China or Russia, as we've seen more lately, to get the raw materials that we need for everything from an iPhone to a tractor to a transistor to a bicycle. So it doesn't really matter what we're building or manufacturing, if you like. The raw materials don't necessarily exist in their natural sense on this continent. So we, and as we do in many cases, certainly in the sustainability cycle, we have an onus on us to make sure that this idea of circularity, this example of using raw materials that over and over again in a circular sense is critically important, not just from some sort of esoteric, we must save the planet and all of that cadence, which is incredibly important, but just from a purely economic fact, we can't get access forever to raw materials that are going to run out. I'll give you one very simple example. I'm a Corkman. I hope you hear that accent from what you're hearing online here. My wife is a beautiful Cork woman, and we both live in the beautiful county of Longford in the Midlands. Lovely, lovely part of the world. And we've been here for the last 2 decades. Wonderful people, a great environment to grow a family and to live. And there are 2 beautiful companies near me. One is Penalto Foods. Penalto is a beautiful organisation, a large company. They build paninis and specialist breads products for Lidl and Aldi and different groups right throughout the country. Brilliant organisation. Right next door to them, literally in the same building estate or business estate, you have a lovely small brewery called St. Mel's Brewery. St. Mel's is a massive name here in Longford. Mel, as we all know, was St. Patrick's first bishop. I didn't know it until I came here. One of my best friends down here is called Mel. This is a huge name here. So St. Mel's. And they make fantastic craft beers. And I'm a man who loves his craft beer. So one of the things, we did a lovely project supported by the EPA, for example, and our own Circulair. Circulair is a PPP that IMR manages here on behalf of the state, and it's the platform for policy on circularity. So if you're interested in that space, certainly check that out. And one of the projects that we funded out of that program was in this Symbio beer, as we call it. So we took the waste bread that came out of Penalto Food, and we used that as a yeast starter in St. Mel's beer. So you had this lovely idea of a waste product coming out of one area as a starter to another. And that gives you a lovely example of the circularity model. Now, I should say that they created a fantastic Belgian beer, very strong, very beautiful, and it's exported all over the world. I have a first cousin in New York who actually had a glass of St. Mel's Belgian brew coming from this particular Symbio beer project with the EPA and ourselves in IMR.
Andrew, a lot of the technologies that we're talking about and kind of looking into the future, how long are these things trialed for and researched before they actually go into mass production and become an everyday thing?
You're a very negative man, Dusty. Good God. These technologies
I just want to be safe.
Want to be safe. My late father, God be good to me, used to say that what happens if concrete doesn't last beyond 100 years, the whole world will collapse around us. There's an extraordinary amount of technologies out there. When we consider there where Barry was saying around Lufthansa and what they're doing, that's an incredibly regulated sector, and rightfully so. I fly on planes myself all the time. It's the safest form of travel, as we know. It's getting more accessible, more safe, and again, we know the green agenda is coming hugely into that space. So a lot of these regulated are the pharma plants and medical devices, and so anything into the human system, etc. All of these are foodstuffs. Our foodstuffs are extraordinary. If you walk into any of the food production companies on this island, we should be very proud of that, in particular from a green perspective, green island, green agenda, and this idea of St. Patrick green all over the world. So we've got extraordinary opportunities at an international level around this. So we know these are incredibly regulated and safe sectors that we're feeding into. These technologies coming on board, and the example that Barry gave us there, for example, earlier on around, adding deposition onto some of these flanges, etc., is very, very safe, very regulated. This is about grasping the opportunity from a technology perspective. We know that in 10 years' time, we're going to be using way more than we're using now. And we're in that transition phase, if you like, to get to that point. And I think I mentioned earlier on off air, I'm sure, around this idea of AI in vision systems. We know that AI in vision systems can now read an oncology scan better than a human equivalent. And instead of doing up to 8 to 10 an hour, we can do over 11,000 an hour. And that's where we find huge help within our systems, because we know that it can add huge amounts of computational power, and the parts that we're finding difficult, the bottlenecks that we have in everything from our health system to developing aircraft and all of these design capabilities, all of that can be brought to bear. Now, that doesn't mean that the human takes a step back or that cognition exits the stadium and so on. There's this whole idea around human in the loop. We don't have decision systems, we have decision support systems. So if you consider technology, for example, is a bit like, how would you say, Google Maps, and you're driving along in your car. Google Maps tells you this is the fastest route to go from A to B. Now you might decide, well, do you know what? I had an ex-girlfriend who used to live down there. I'll go down and see how that house is like this. And you'll go left at that particular junction, and we'll just readjust and say, okay, I get it, you're going somewhere else, but you're still going to point B, and you want to be able to find and plot that line. It isn't that it's going to take over the world. We're not quite at Huxley's Brave New World at this point, but I think that doesn't mean that we should abdicate our responsibilities and the human element in this. And as I mentioned there to John and Barry, I'm not altogether sure that, AI systems coming in, and we know how people feel about AI, and this is very much an age thing as well. I should point out that, when your young daughter or son picks up an iPhone or an iPad and they're sliding past and they're using it and so on, that technology to them is the most natural thing in the world because it existed when they were born. Whereas if you look at how your parents are looking at it, saying, I don't know, young kids, they're always on these screens, I think it's negative and so on, because that didn't exist. We know, for example, AI gets an awful rap because AI is everywhere. The minute it becomes a useful technology that we can understand, it stops being called AI and it starts being called Google Maps or Google Search Engine or something else that we're used to seeing, how we Alexa and all these things, that's all AI. But the stuff that we don't know and that we're still cognizing about and that we're pushing forward as conceptual based and so on, that has that term AI. So I think those are things that we should be very, very conscious of. But I don't think that, as I was saying, I don't think that we should abdicate the human role in this from a psychology perspective, from a philosophical perspective. I'm not altogether convinced that, people who get this type of technology, people who understand it, people who are advocates like myself, that we should be using it and can see positive contributions and so on. There is a whole pile, including a charter for AI. What rights does an AI entity have, for example? There's already there's a human charter, we now have an AI charter, which is accepted at an international level. So how we engage with this is something that keeps, as I said, not just the human in the loop, but the human at the center of that loop.
John, let me go to you and ask you about, because of something yourself and Barry both mentioned, Industry 4.0. What is Industry 4.0?
That's a $64,000 question. Yeah, I started, as I said, my own personal research, and I had a look around and because what is Industry 4.0? It's a buzzword. It came out of Germany. It came from the German government back in the early 2000s as how they would, what's the next step in industry. So Industry 1 was the manual labor transforming to steam power. Then Industry 2 was electrification. And then Industry 3 was electronics and automation. So we're up to the 80s. And now we're on Industry 4.0. And we're, as Andrew said, we're on Industry 5.0. And a lot of industries now are coming along with pharmaceutical 4.0 and food 4.0 and so on. So what we're doing here with the Industry 4.0 is it's about cyber physical systems. So we're linking the technology with the hardware and getting data. And I found the OECD came up with 9 technologies and techniques that they would call Industry 4.0: autonomous robots, autonomous machines, IoT, Internet of Things, big data, cybersecurity, augmented reality, artificial intelligence. Andrew covered. So it's really a hodgepodge of lots of new things. And I think the one that I'm focusing on next is the simulation and what people are calling digital twin, which is going to be the next phase of, I think, the next kind of accelerator for manufacturing.
Okay, well, come on, you said it, so you have to explain. You're talking about paper, you're talking about digitization. Yeah. Tell us about digital twin.
Digital twin it's very exciting. So the first time I saw a digital twin was about 10 years ago, and it was, the diving bells that go down to that the divers use to service the platforms at sea.
I do.
So there was this ship where they went out to the platforms at sea. They had this big diving bell, and they brought down the divers, and they had to acclimatize and so on. So to do the training and bring that ship into dock and do training, it was costing them hundreds of thousands of pounds a day, because the ship wasn't producing or wasn't being effective. So they developed an entire simulation of the diving bell, the pressures it would encounter, the technologies on board, the control room on the ship, and they put it on shore, and they had cameras, they had animation, so everyone felt they were performing in the real world. And it saved a fortune. You could train, you could commission, you could make changes. And if you wanted to make a change to the actual machine, you could make the change virtually first and test it and then bring it to the real machine. So digital twin is, we've digital twin cities, we've digital twin machines, we've digital twin products.
So this has been happening for years, I know, in the aviation industry with wind tunnels and modelling and all that kind of stuff. So you do have a twin. Are you saying that this is happening now more and more in, say, regular life?
Well, on the one hand, it's to do with cost. You can virtualize your process, virtualize your product, and commission and train your operators and your staff before you invest in the product. But even now, I'm finding people who would never have used digital twin are now saying, well, I have supply chain issues. I'm not going to get the parts for 2 years. What are we going to do in the meantime? So let's build a virtual machine, and then let's train and develop it while we're waiting for this hardware to arrive. So it's interesting. It's probably the next thing we'll be looking at, because we haven't got there yet.
I was about to ask, do you do it yourself? But you're thinking about it, and it's something you get into. Speaking of aviation, Barry, you're with Lufthansa, and I mean, digital twin must be something you've been doing for years, is it?
No, it's interesting. When John spoke about it, I was speaking with Conor McCarthy from Confirm, the organisation here in UL, and we're going to have a postdoc come on site in the new year to look at developing a digital twin for our additive manufacture process. We've got a lot of data that we've gathered as part of our research. We have a lot of results from our metallurgical evaluation of samples, and the idea is to build a digital twin of the process and then use the digital twin then to help us optimize the process. But it was interesting, John, you're talking about using a digital twin maybe where you don't have material or whatever. When we have a new engine type that we need to develop repairs for, we typically don't have parts to work from. So for us to build the 3D model of the parts and then to model the process and create a digital twin would be extremely beneficial to us going forward. So it's not something that we're necessarily using at the moment, Dusty, but it's something that we see the opportunity and really need to understand how best we can deploy it in our business and get the most from it. And as I say, we're starting off with that PhD or postdoc student who's going to work on a project for us to explore the value of it to us, really.
Let me ask you, Barry, because you've worked in several different countries around the world, and we're getting excited about digitalisation and digital twins and all these things we could do. Is Ireland kind of lagging behind, or are we keeping up to speed with other countries you'd have experience of?
I think what's interesting, Dusty, is I think it was John that mentioned that Industry 4.0 originated out of Germany back in the earlier 2000s. And one of our strategies is to try and collaborate as much as possible within the group. And certainly when I compare what we're doing with what our colleagues in Germany are doing, it's very much aligned. We're maybe somewhat on different paths, but they're looking more at the aircraft and the engines at a sort of a macro level, whereas we're down on the detailed parts that we repair, looking at how we can apply digitalization to the actual processes used to repair the parts. But I would say we're very much keeping abreast of our colleagues in Germany anyway, and trying to share as much our knowledge and experience to help each other and collaborate as much as possible.
And do you find that there is a lot of that where you will go to Germany or other countries and you'll be inspired by something and then you'll throw in your tuppence worth and they'll go, "Whoa, Barry, good idea."
No, absolutely. Our key projects, or what we call our lighthouse projects, we would share that with them. The other area, I think, is just within the region here, we have a very active network called Explore Engineering. And that's a network between the universities in the Midwest here and the industry in the Midwest. And I think it was fascinating, really, because we talked about the manufacture of knees and hips and that. And we've got Stryker here in our region. And we've collaborated closely with them because they use a lot of the same technologies in the manufacture of hips and knees as we do in the repair of airfoils from aero engines. So I think it just goes to show the great opportunity we have on this particular topic to collaborate. And over the years, we developed a very strong lean network where companies collaborated on and shared experiences on their lean journey. And I think there's a great opportunity for us to network industry together to share our experience on digitalization. And I suppose our most recent step forward was to consolidate our digitalization program in with our lean program, our CI program, because I guess when we set out on our journey, we saw digitalization as projects more like NPI projects, and we managed them with a gate process. And then we I suppose to spread it across the organization, we looked at training across the organization. So we've had 20 of our staff across the organization do the UCD diploma in digital transformation. And it was out of that we really looked at, were we looking at a digital transformation in our organization, or was it more incremental improvement? And really we decided it's incremental improvement we're looking at. So when you talk about CI, continuous improvement, under the Lean umbrella, we're effectively doing CI using digitalization. And so to bring the two programs together made a lot of sense, because we're using and sharing the same resources, but it brings another dimension to our CI program when we talk about digitalization and opening up another world of opportunities for us. And part of the problem is we didn't have the knowledge in-house, we didn't have the skill set maybe to really go after some of the digital opportunities when we looked at CI. We looked at other non-digital opportunities, let's say. And I think having trained 20 people on the diploma course, we now have people that are more aware, I suppose, of it, and are looking for opportunities to make improvements through digitalization. And that's why I think that network would be really good, to try and have companies share experience and learn. We're not competing against each other. We're actually collaborating and helping each other. And there's really a lot of opportunity there going forward.
And you kind of all need to speak the same language as well. And what you're doing is helping them to do that. Just to wrap up our podcast for today, John, after listening to what Barry has been talking about, or Barry listening to John, is there anything you would like to ask each other? I'll let John go first on that.
Yeah, Barry, I'd like to maybe touch base with you later about the digital twin journey you're on and your IoT solution. Did you call it?
ThingWorks is the platform we're using, and
it's the next step that we're looking at. And
well, I'd equally like to talk to you, John, as well, because I think what we're trying to do with Connor out in Confirm, certainly interested to get your input.
It started off as a podcast and now it's Tinder. it's like, what's going on? So listen, John, what is it that interests you about what Barry was saying that you're thinking?
No, just the simulation and the digital twin of the product and the digital twin of the process, and how that will affect the real manufacturing then is fascinating. And the key is the feedback. You have to close that loop and get the data out of the factory floor and into the digital twin.
Yeah. So
that the digital twin is continuously improving in its true nature, that it's catching up with the real data. And you'll find then that you have gaps. Okay, we don't have enough data to be accurate. Let's add sensors. Let's gather information.
And Barry, what is it that John was saying that you're going to follow up with after the podcast?
I suppose if I just take a step back, maybe just see, one of the big challenges I found in trying to take an organization like ours, like we have 250 people, so we're not a small company, we're a highly technical company, and yet I really struggled to get digitalization embraced by the organization. I mean, if you look at it from a financial controller's point of view, they're immediately looking, well, what's the return on investment? So I'm looking to try and get projects that I don't even know myself what it'll deliver. So we need to understand what a digital twin can do for our business before we can really put a project together with an ROI on it. And when I started looking at some of the other projects where we're looking at process monitoring and dashboards, how do you say what the ROI is going to be on it? And if you want to invest in an IoT platform before you even have a whole lot of projects that are going to go onto it, it's really difficult. So one of the concerns I have for industry in general, if you take the smaller companies who maybe don't have the resources we have, how do you support companies like that to take that step forward, that leap of faith, I suppose, into digitalization? And certainly is still seen as a buzzword. Industry 4.0 is a buzzword, and to some people it's like the engineers are it's a game, or they're toys to play and experiment with, and that's a big concern, I think.
Well, let me ask Andrew about that then, because Andrew, we're talking about digitalization and developing things, and you can do this, and it's all amazing. And it sounds great for a big company that has the resources to do it. Because you have more of an overview of industry, do you find that this is filtering down into smaller players?
We've got to educate our own managers. Not that this is something they could do, but this is something They have to do. And the problem is, and I often give the example there of hearing aids. Hearing aids went from dust press or compression pressing or vacuum molded and so on to being 3D printed. It went from a couple of euros to a couple of pence. If you had an organization that was doing the latter, you were going to be out of business within 9 months. It happens that quickly. We know that there's lots of medical device corporations at the moment at an international level that are looking at 3D printing. Now, if they get 3D printers in that manufacture their product, what's that going to do to their supply chain that's currently making plastic molds and parts for them? And the tool makers that make the tools and molds for those plastic part manufacturers. That's a supply chain that could potentially be decimated, and we need to understand what that looks like and so on. If we look at our car manufacturers, people supplying product into cars at the moment, as cars transition from fossil fuels into electric, anybody who's making parts for all of those, that's going to change significantly. If you're a company that makes buttons and panels for anything, what you're going to find is the buttons are gone. They're now on screens. We all want sliding screens and we press stuff instead of having small plastic buttons and so on. So there's a revolution in terms of what it is that consumers are looking for. We're going from plastic parts to electronically enabled smart things, and we need to be on that journey. It doesn't matter what sector you're in. If you're a food manufacturer, for example, and you think that 3D printed food is something that will never happen, you're wrong. I've eaten a carrot that was 3D printed. I've had a scan of my entire body. They gave me a little doll. It's not the cutest doll I've ever seen. It's a bit freaky, but it's a doll nonetheless. So it doesn't matter what sector you're in. This is coming for you. And if you think that I can stand still and do nothing, and I've got a good business, and I'm going to be all right, Jack, you're not. Because regardless of whether it's the regulatory environment that's coming down from a circularity perspective and is looking to manage and maintain the information through that data stream, or whether a multinational supplier for you is going to come through it, or even a B2C customer, for example, there's a whole pile of legislation coming down that I manufacture a machine, give it to a customer. I'm still responsible for the data infrastructures for that for 17 years after I sell it, 14 years after I sell it. So these are things that are going to put huge pressure on all systems, some of which and most of which are going to be SMEs. But I think back to how I thought of ISO when I first came across it and said, good God, we'll never climb this mountain. And now it's a hill. It's a very small hill because we can all, have the infrastructure and the knowledge and the mindset and the budgeting and so on to make that happen. This is just another hill in the making.
I'm actually kind of going to give you the last word, Andrew, in a way, all right? Because is there anything from what Barry or John was talking about earlier that you'd like to ask them?
John O'Sullivan, very serious question for you, my friend. Collaborative robotics, nonsense or the wave of the future?
I would say for us, we've used them and we ended up backing off from using them. There were limitations around their capacity and their accuracy. I suppose there's a trade-off between the collaborative nature and then what they can do. Basically, how heavy can they lift and how accurate can they repeat a task? So we've used them and then we've gone back to call it traditional robots from the big name manufacturers, KUKA, Mitsubishi. And then you have to install overarching safety systems around them. So for Dusty, if you're not familiar, a collaborative robot is where you can actually have a robot on the desk with you and the human being is handing parts to the robot. The robot is taking parts. So it's in the name collaborative. But for that, you're dealing with a moving part that can be dangerous and it has to be managed very carefully. So I would say there's a future there, but we've not had the case studies to use it. Can I just make a point to reiterate something that the lad said about the SMEs in Ireland? I think you might say, yes, Andrew, that we don't have enough robots per 100,000 people, but we're in a process industry where robots aren't required. We're moving liquids around more than parts. We don't have that OEM base that the Germans and the Italians have. So I would say we're probably digitalizing elsewhere, apart from robots. What we do need to do is, and this podcast is part of it, we need to build clusters of expertise where companies like mine, we have the advantage over Barry in that we can see what the other customers are doing, we can see what the other industries are doing, and we can take the best from each and deliver it to someone like Barry. We can take knowledge from the medical device, from the orthopedics, and bring it to automotive, bring it to aerospace. And those clusters are key to the growth of the industry in Ireland, I think.
Well, gents, it's been absolutely fascinating talking to all of you. And I definitely get the impression that not only is digitalisation alive and well in Ireland, but we're as good as anywhere else in the world, which is good to see. I won't say we're better, but we're as good as anybody else in the world, which is great. Thank you so much for coming on to the podcast today. John O'Sullivan, Managing Director of Douglas Control and Automation. Barry Lowe, Engineering Manager at Lufthansa Technik Turbine in Shannon. And Andrew Lynch, Chief Innovation Officer at Irish Manufacturing Research. If you'd like to look up any of our guests, you'll find their contacts and LinkedIn profiles in the show notes area of your podcast player right now. Our Amplified podcast was produced by dustpod.io for Engineers Journal. You'll find advanced episodes on our website at engineersireland.ie, or just press follow on your podcast player right now to get our next episode automatically. Until next time, from myself, Dusty Rhodes, thank you for listening. Talk soon.